133. Oh, all right. So this is a lot like I think the last word problem one that we set up. Put you right there. Stay. All right. So yeah, Jeff. Photographic memory you do not have. 33, right?
Yeah.
So I don't know if you guys remember, there's that one we did in the green book. It dealt with the angles. I think it was that first one in the green book. Yeah. What's wrong with that? Why does that first equation suck? Especially compared to the other two. It's got way too many variables. Notice how this one tells you what y is in terms of x. It's telling me what z is in terms of x. Can I use that information somehow?
Can't you just plug it in?
Yeah, if y is this, I could put this there. I could put this there. And then I have an equation that has only x in it. Is that, yeah. And then once I know x, I know y, and I know z. Because I just plug the value in. Anytime that there is one or more letters missing somewhere in the whole thing, there's a shortcut way to do it. Yeah.
So you just put the y and z in and then solve it.
Yeah, because this is x plus something with x plus something with x, so that I can solve for x.
So you solve x and that's
And once I know x, I plug it in, I know y. I plug it in, I know z. Done. Sweet. Because the answer to a system of three equations will be a three-part point, right? X, y, z, or whatever letters they give you. A, B, C, whatever. All right, I like it. Feel better? I was concerned. Is it rough out there right now with the parking? Or are you guys just like...
It always is.
It always
It's pretty
is.
bad coming in.
Kind of relatively bad?
Yeah.
All right.
Noon is when everybody gets out.
What's up?
Noon is where everybody gets out.
Oh, I see. Yeah, I know. Around noon is where I just sit in my office and wait for a while. I don't want to get in that line trying to get out. Anyway. Okay. I get here at like 5:30 or 6, so I got all kinds of... Yeah, Jeff, sounds good. I'm not going to do that. I don't blame you. All right. Anything else from homework? Nope. Yes?
4.2 for 45.
This is 4.245.
Yeah.
Oh, all right. So guys, I don't know if you remember these words: complementary angles, supplementary angles. Always remember alphabetical order. Complementary is the two angles that make 90 degrees. Supplementary is the two angles that make 180. I like it. C goes to 90, S goes to 180. It's alphabetical order, right? Guys, so if I told you that two angles are complementary, how can you write that as a mathematical equation? Two angles are complementary.
2x equals 9.
I never said that they were the same angle.
Oh.
Two angles
A plus B.
are complementary.
A plus B equals 9.
A plus B equals 90. A would represent the size of one angle, B is the size of the other angle, and I know together they make 90 degrees. If I said two angles are supplementary, A plus B equals 180. I like it. So this problem's got, this is 43, right? Or 45? Two angles are complementary. So that's A plus B is 90. their difference is 18 degrees. So my two angles are A and B. They're complementary, so A plus B is 90. Their difference is 18. So how would you write that? Their difference is 18 degrees. A minus B is 18. Difference is subtraction. I like it. You guys are all right? You guys are physically here. That's half of it. Yeah, it's sort of the last day of the week. I understand that. Trust me. I'm sure you guys would not have moaned too much if I canceled class, but let's do it. Here.
You can always do
Does that help you out? Is that enough? Who asked that question?
Yeah.
Is that good? Okay.
Right. You can see your videos at home. Right? Get your whiteboard at home. Do it from your bed. Straight. We don't have to go to school.
This ain't no online course. I'm pretty sure I said that at the beginning of the semester. If I don't see you in this classroom, that's bad. Right? Those days that there's technical difficulties, the days where there's technical difficulties and the video don't make it, you're screwed.
That's why you get two phones like Kevin Gates. You're good.
I ain't gonna do that so you can sit in your ass in your bed.
You can sit in your bed too. It's a win-win.
No. That's not why I became this. Obviously. All right. See, we would miss out on this, man. This interaction. This is great. Anything else from homework? Yes.
Number 34 on 9.1.
All right, now this one is a freaky one. All right. Is that what you said? Michael Scott. There you go. Somebody got that. Let me see. 34, right? Yes. Yes, huge tracts of land. Now this one's missing a lot of letters, but it really kind of sucks. Right? I mean, it's not set up the same way as the other one. The other one was beautiful. Y equals Z equals all the X stuff. I can just throw it in. No, this is not. No. So one way to look at this is I have an equation with L and M in it. So one way to do this is if between the other two I kill N, I'm going to have another equation with L and M in it. So this isn't as easy as the last one I had up on the board, but you see, it doesn't really matter which equation I pick. If I just pick the first one, what letter am I already missing? N. So it's like somebody already killed N for me. So I just have to kill it one more time. And then I'll have another equation with L and M. And then between those two, I can kill L or M and figure out the other one. Are you guys semi with me? So the first step would be, between these two, how do I kill N?
Multiply that by the bottom equation by 2. The third equation.
By negative 2. I like it. So I leave this guy alone. And then I would multiply this by negative 2. So I get negative, oops, where am I at? Negative 8L minus 2N is negative 10.
3 minus 8.
So then, now watch this. This is where you gotta be careful. These cancel. 3M minus 8L is 3M minus 8L. 9 minus 10?
Negative 1.
Negative 1. So I've done part of the work for you. There's one ML equation. There's the other ML equation. So between those two, you can kill L or M. Right? Obviously. Well, not obviously. You can pick whichever one you want to kill. You guys? Because what's the purpose? Kill a letter twice. What if it's already dead once? Well, then just kill it one more time. Because you want to kill it twice.
Bring it back to life.
Whatever gets you through. This is where you can get some aggression out on variables.
Thursday.
Die.
Does everybody
You okay, buddy?
Does everybody get that idea? It goes right along with the basic idea of too many letters, let me kill it, but they already had something dead, so I just had to make it dead one more time. Okay, maybe. I guess, no. All right, so I got the first step, and then the rest of it follows the same way as always. Between this and this, I could even use substitution if I wanted to, right? Solve for L, 7 minus M, and plug it in. Or you can multiply this by 8, because then the L's would kill each other. Right? So then you, is that cool? Whoever asked that question? Is that all right? No? Alright, so what's up? You know where to go from here.
Not really.
So here's my L plus M, 7. And down here, let me turn this around so my L and my M can line up. Negative 8L plus 3M equals negative 1. Now, between those two, can you kill L or M? Yeah, you can kill either one, to be honest. Yeah, so if I multiply the first one by what, I can kill M? Negative 3. Yeah, there, keep going. The idea doesn't change just because the original had some stuff missing. It actually becomes quicker. N is already missing, and we make it missing one more time. And then I can do like always. Okay.
Should we solve the equation on your shirt?
No, you can't. This is a little teaser for you. If you get much further in math, you'll understand what this is about. It's called Euler's identity. Spelled E-U-L-E-R.
Oilers?
You pronounce that Euler. Yes.
Must be French.
Not French. Leonard Euler. Anyway. You guys know all the symbols in this equation?
Yeah, that's E, that's
You know pi,
That's pi.
right?
Is that imaginary equal?
You know 1, you know 0. Some of you guys might know I.
Imaginary.
That's an imaginary number. And some of you guys might know E, which is related to throw a couple of rabbits in a room, give them some food, and the population grows.
E equals MC.
It's not that E. It's not Einstein's energy equation, no.
So that times imaginary number times pi plus 1 is 0.
E to the I times pi plus 1
is 0.
equals 0. It's some freaky ass cool
The
shit.
shirt just says it doesn't make
There's
sense.
no negatives.
The only reason it doesn't make sense is you don't know enough math to understand it.
So
Which is not a bird. My God. I don't know how to freaking play a guitar. So it's all about what knowledge do you have and what don't you.
So is that how to do the problem on the bottom? Or is that
No, the bottom is just sort of a visual of
how to...
this is how where it comes from. Yeah. Anyway, all right. Enough about my shirt. I also taught calculus this morning, so
It's fresh out.
Calc 2 is where you learn this. Calculus 2 is where you learn how this thing
How far is
works.
that from here?
Let's see. So you got well, if you take pre-calculus and then calculus,
After this, you can
so
do
it's
pre-calc?
3 steps away.
You teach
Yeah.
pre-calc?
Not next semester, no. We just picked our schedule, so anyway.
For next semester? Sorry.
What's that?
You already picked your schedule.
Yeah, we picked our schedules for next year. Yeah.
You have to-
All right. Let's get some stuff done, guys. Rein it back in. Anything else from homework stuff? Okay, so what we're about to get into is this section 4.3. I'm sorry, 9.3. That deals with a different way to solve these kind of equations. So let's start off with, we're going to build it up to what I call 3 by 3. 3 equations with 3 unknowns. So if I said 2 by 2, that'd be 2 equations with 2 unknowns, like x plus y equals 7, and so forth, right? So let's do this. If I had these equations, I guess guess this should make it work. That would be nice, Jeff.
We know what's going on in your head now.
Yeah, exactly. That's why I tell you. So we'll see if Jeff did this correctly or not. It'll be exciting. If I have them lined up, does it really matter that this is X and Y? What if this was A and B? As long as this was A and B, right? As long as they're in the right order. In fact, what is it that I would do first to start this, to do elimination on this? Multiply
Kill the
Multiply the top by
Positive
2. Let's focus on the x's for right now. Yeah. So I multiply the top by 2. What told me to do that? Did the x tell me to do that?
the negative 2.
The numbers told me to do that. That's a 1, that's a negative 2. So what this method does, I have to warn you ahead of time. Most of you will probably at first rebel against this method a little bit, and I don't blame you because it's new. My claim is that the method we're about to learn will make 3 by 3 easier. When we did this problem here, how did it relate to that problem in terms of how long it took? Yeah, like days, right? Right, now, we're not going to do this, but can you imagine if I had 4 equations with 4 variables? So the amount that it increased in length and complexity from here to here, it will increase by that times that again. And then if I make 5 equations, holy shit, right? The method I'm going to teach you today would take about the same amount of time from 2 to 3 to 4 to 5. Because what it does is it refocuses us and it makes it more into a game of making zeros and making ones. And when we get there, you'll see what I mean. It takes a lot of the shit that doesn't matter out of the way. All that matters as far as the variables go is that they're lined up like terms, right? Kendall, can you do me a favor? You're all right, sorry, man. I just didn't want to trip. I knew I was going to trip eventually. So now watch, here's the first step with this. Rewrite this just bringing out the coefficients. So what are the coefficients of the first equation? Coefficients. 1, negative 1, 4. I put a line here for the equal sign. Is that? I don't think the book does, but that's the way I was taught. I can't stop myself from doing it. And then for the second row, second equation.
Negative 2.
5, negative 2.
All right. They gotta stay with me. What's gonna suck at first is I'm gonna do a lot more work than I would this way because I have to kind of show you why things work the way they do. So the amount of time it's going to take us to do this is longer than it really should be at first because I got to kind of show all the steps and not skip anything. And you with me a little bit? Okay. I'm going to start to introduce little shortcuts that really is the real way to do this. The more comfortable we get with the idea. So you are going to not understand why we're doing this first because it is going to take longer to write shit out. But that's because you don't know matrices, right? So we got to get used to them. And then we start to bring in these shortcuts and then you'd be like, oh, this kicks ass. This is so much quicker than before. Now, I will be honest about this. For a 2 by 2, matrices always take a little longer. 3 by 3, about the same amount of time. 4 by 4, oh my God, matrix kicks the other way's ass, right? The whole by hand bullshit. And 5 by 5, forget about it. So here's the idea. I'm refocused now. Before I wanted to kill the variable. Now I want to make a 0 show up in my matrix. Right? That's going to be our process. Now let me ask you this. What does the answer look like? What would an answer look like for this? Like x equals 2, y equals negative 1, right? That's a possible answer?
Yeah.
You with me? Okay. What would that look like in matrix form? Well, this is 1x, no y's, equals 2. And this is no x's, 1y equals negative 1. So if I can take this and make it look like this, these are the answers. Because what does it mean if I make a 0 show up here? That means that I've killed that x, right? Okay, I like it. I like it. So when I say row, it's the same thing as saying equation, because a row represents an equation, correct? So what is it I'm allowed to do with these two rows? Anything I was allowed to do with these equations. Could I flip the rows around? Could I put this row first? Of course, because I could have written this equation first, right? Can I multiply all the numbers by something? Yes, because it's the same thing as multiplying both sides of this equation by something. Right? Can I add these two together? Yes, it's the same thing as adding the equation. Can I multiply these together? Hell no. That doesn't make any damn sense. If you multiply this equation by this equation, you FOIL this shit out. Oh my god. Then you start making x squares and y squared. No way in hell we're going to do that. You guys with me? So there are certain things you're allowed to do. You're allowed to switch the rows. You're allowed to multiply a row by something. And you're allowed to add them together. Yes, sir?
So the top row you would multiply by 4.
No. What would you do here to kill the x's? Multiply the first equation by 2. So here, what am I going to do? I'm going to multiply the first row. So here's how you do it. You ready? All right. And again, I'm going to say this over and over again because I know from personal experience what it's like to kind of learn this and go, whoa, what's wrong with the old one? At the beginning here, we're going to write a lot more than we normally do. You do have to tell me something, what you're doing. Don't just have things change and I have no idea what you did. So what do I mean by that? What am I about to do? I'm about to do twice. Let's really take this step by step. I'm going to do a lot more steps than I normally would. And we're going to do a couple examples and we're going to try to take some of the steps out to make this a little quicker. So if I double row 1, what's it look like now?
2.
8. I like it. And now what are we going to do? The whole reason we did that is so we can add them together, right? When I add the rows together, I need to put the answer. So I'm going to overwrite one of these two things with the answer. Because I always want my matrix to have the best equations. It's going to have the best equations. Right, that was a bad impersonation. Get the best roots.
Are we making equations good again?
What's that?
Are we making equations good again?
Man. There's a wall there. I'm going to take it out. So if I do this, I got to tell myself and, like from you got to tell yourself and me what the shit you're doing. So what am I about to do? I'm about to add row 1 to row 2. You got to power through this. There's a lot to get used to. And I know that. What was the goal again? Our goal again was this. Because if we get here, what's that mean? That means x plus no y. So x equals number, y equals number. That would be, I'm done. That would be the answer. So this is what I meant earlier by, what's this become now? A game of making zeros and ones. So it kind of refocuses us. Where do I want to put the answer then? When I add these two together, I'm going to get what?
0.
0. Where do I want the 0 to show up?
On the bottom.
On the bottom, in row 2. So I'm going to put the answer in row 2. Does everybody understand what this little sentence means? It's telling me what the shit you're doing, and it's telling me where you're putting the answer. It's also telling you what you're doing. If you don't write this at all, and you go back through a problem, you have no idea what you did. Why is that a 3 now? I don't know. Yes?
Is that a formula?
That is a goal. It's not a formula. How do I know I'm done? When I have x equals a number? Here, real quick. All right. Let's see if I can throw this in the middle of this problem. Just stay with me. Little side note. Side note. Can somebody tell me what are the two equations that are in this matrix right now?
3x plus 5 equals negative
3x plus
5y
5y.
equals -1. And then 2x minus 6y equals 4.
So what are the equations here?
X equals 4 and y.
Yeah, x plus no y. So x equals 4.
And then y
No x's plus y. So y equals. So this represents the end. It represents I'm done killing stuff. I can just read the answer off now.
I have a question.
Yes.
How did you get 4 and negative 2?
No. These aren't. These are two. So 1, 2. Okay. This is nothing connected. I didn't do any work from here. This is just a separate thing. Here's a matrix. Can you read it?
Yeah.
Here's another matrix. Can you read it?
Yeah.
It was just a quick side note. I'm not doing a whole other problem in the middle of the problem. No, but they're not connected. Is that cool?
Yeah.
Just can you read it? So that explains why that's where I'm trying to get, because that means those are the answers. So maybe. Stay with me now. Stay with me. It is worth it.
We're with you.
Plus, you just got to be able to do this so you can pass this part of the course. But so what do I get when I add those two rows together?
Cancel?
0.
So 2 minus 2 is 0, and I put the answer in row 2. Negative 2 plus 5,
3.
3. Put the answer in row 2. 8 minus 2, 6. Put the answer in row 2. And the first one is still this. Let me stop for a second. Stay with me. Now,
You sound like the Titanic. She's like, stay with me, Jack.
oh, got it. All right. I like it.
Draw me like it.
All right. So, all right. I'm going to try to get you to start thinking about a shortcut. Why did we double that first row? What was the only reason we doubled it?
To get rid of that one.
To get rid of that guy. The minute he's gone, does this row still need to be freaking doubled? No. Okay. So we're going to do another problem after this one. I'm going to start to introduce a few shortcuts. So on the side of this is still the same thing, right? But now what does this first row represent?
2x minus 2y equals 8.
And this one, of course, is the same as before, right? And sure enough, if you add those together, what do you get?
3y.
3y equals
6.
6, which is what that represents, right? So writing the equations in this form, where I only keep track of the coefficients, it makes sense because the letters don't matter worth shit as long as they're lined up. What is it that actually tells me to double or to do whatever else is the coefficients. So this method said, let's just not write the freaking x and y forever. Let's just look at the numbers.
So did we find y already? Because we got 3y.
Yeah,
equals
dude, what
6.
can I do with this row now?
3y equals 6 is divided by.
Yeah, so I can do what to this row? This first row I can divide it by 2 again, right? So it's row 1 divided by 2. And let's see if we can handle if I can do row 2 divided by 3. Yeah. So the first row goes back to what it was. I divided by 2. So sort of like just taking this back to what it was. I only needed that to kill the other x. This still works. This is still true, this equation. This one becomes divided by 3. So we already know that y is 2. I like it. Now this one, I didn't plan ahead for this. This is almost too nice. What's still not right with my goal? What's not correct?
The 0 right there.
I need a 0 right there. I love it. Can you guys see a quick way to do that?
Divide it.
No.
Add them again.
If I add this row to this row, 2 good things. It won't screw with that 1, and it will kill that negative 1. Right? Because remember, what's my goal? My goal is 1, 0, 0, 1 with numbers. So I got everything ready except for that. Oh shit, I need a 0 there. Okay, add these rows together, won't that? Right.
Wouldn't that just give you 1 3? Where do you
No, it doesn't. What you do is you never lose an equation. You just write over an old equation. What do we do from here to here? We wrote over this one.
Right.
This one, I said, you screw you. You have too many unknowns. This is a much better equation. And the other one stays.
Okay.
So the matrix is always keeping track of what's the best current equations I've got. So what happens if I add row 1 to row 2? Where do I want to put the answer?
For 1?
Up top.
Up top, row 1. Row 2 looks beautiful.
Yeah.
I want that 0 to show up in row 1. So when you add these together, what do you get? 1 plus 0 is 1, that's crazy. Negative 1 plus 1 is what we wanted. 4 plus 2 is 6. And then this guy stays the same. I didn't do anything to row 2, right?
So will it always work out that way? Because in the first...
It won't. What if there would have been a negative 4 here? I would have just had to multiply this row by 4 and then added it together, right? We just got lucky these both happen to be 1s. Is that cool? But basically...
No, I mean, it'll always work out to where you write the answer on the top, right? You keep the bottom one the same?
Whatever matches with getting you closer to your goal.
Okay.
How did I know to put the answer there? Because this is already at the goal. Yeah. Yes.
So now, like, the answer would just be 6.
6-2. So the answer is 6-2.
Yeah, and which one's ending with?
Yeah, which I had forgotten. That is what I made it. I was like, that doesn't sound familiar. I don't even remember what it was. Oh, yeah. Okay. Let's do another one. And this time I want to introduce a shortcut in there. See what you guys
There's already
think.
a shortcut to the shortcut?
What's that?
There's already a shortcut
So like I said,
to the shortcut?
I'm doing more steps here than I really have to.
Yeah.
Right? And the real big place that I did more than I had to is right here. Look at all this time I wasted rewriting this matrix when I only needed this doubled for a second, and then it went right back to what it was. It's like, holy shit, well, I got a lot of writing that I didn't need.
That's already quicker than the last one.
Okay, if you guys think that, great. This is actually longer than it would have been if I would have just done it directly. I don't know if you guys realize that, but I'll take that whenever I can. Let's do another one. All right. So what if I had, well, what you got, John? You can do it, John. You can do it.
Self-motivation.
Yeah. All right, I think that should work. So try to write what the matrix looks like. Just try to convert that into a matrix. What'd you do in school today, honey? Went to the matrix. It isn't horribly evil to write this as a matrix, right? It's just collecting all the coefficients. Is it lined up correctly?
Yes.
You got to make sure if they had yx and xy, please, dear God, realize you got to turn that sucker around. Matrices work assuming everything's in the right order. So what's it look like?
3, 5, 1, -2, -4.
Now, another thing to this. When I grade these, I grade based on, do I see evidence that you understand the procedure? Why do I say that? It's so freaking easy to forget a negative, and then you ain't got a chance. You understand? That is remarkably frustrating. You do it, and you get to a point where you're like, you get 11 over 73, and you're like, this can't be right. Please, dear God. So don't erase all that shit. Keep it. Maybe you get another piece of paper, start over, but I look for evidence that you understand what to do. If you forget a negative, I can so desperately relate. Right? Young Jeff with his 7x7 matrix. Fractions everywhere. Yummy. Doing it by hand. And I'm writing 2/3 and I write 3/2, right? And I'm screwed. Right? So I can totally relate. So pretty cool with that. That's not bad. What's kind of wrong, and right off the bat? Now we could have been smart about this before we wrote the matrix, but I didn't even want to give that away yet. What's an immediate thing I can do? What's my goal again?
0 to 1.
Be more specific.
1, 0.
1, 0,
0.
0, 1. Number. So already, do you see a 1, but only if it was in a different place? It'd be great.
In the last
So I can just take these and flip. I like it. Is that really, really crucial? No. But when you're first learning this, it's good to just really keep it very, very rigid, right? So here I'm going to just switch row 1 and row 2. So when I wrote the matrix, I could have just wrote them in the other order to begin with.
So you'd rather have the 1 on the top?
Yes. And for right now, again, we're really not used to this stuff. I want to keep it very clear. This is my goal. Get to your goal.
Specifically, 0, 0, 1.
Yes. So I want that 1 up there. Then when I read off the answer, the first number is the X, the second number is the Y, and when we get to 3 of them, the third one number will be the Z. But if I have this out of order, maybe not. Oh, shit. So now switch these around. All right, now what can I do?
Times by negative 3.
Yes, I hear one right thing and one, I'm not sure. I can get rid of that 3. Right? Now do you see how, what's my primary goal with the matrix? Get zeros. What's the easiest way to make zeros happen if there's a 1 somewhere? So I'm trying to make 1 so then I can use the 1 to kill other shit around it. Right? You start to see how you're kind of changing the way you're looking at the problem based on the way we organize it. So what I'm going to do, I'm going to take row 1 and multiply it by negative 3. Add it to row 2. Put the answer where?
Row 2.
Row 2, I love it, because I'm going to get a 0 there, and I want the 0 there.
And then when you rewrite your top equation, you're just still going to have that 1 there. Right?
You ready? So here's my first little shortcut for you. If you don't like it, you can do the problem like I did in the first example.
So even though you switched them, the top one is still row 1 and the bottom one is still row 2?
Well, now it is, yeah. So once I switch row 1 and row 2, now what's row 1? 1, negative 2, negative 4. I like it. I like it. So now, watch. Let's see if you guys can handle this. Do you remember on this problem, why did I write this shit when I immediately made it back to what it was?
So you could see what you were doing.
True. So I'm still going to do it, but I'm going to do it like this.
So both of those are becoming row 1? Or am I going all the way?
You're going crazy.
Okay.
When I switch row 1 and row 2, this guy was row 1, he is now row 2. This guy was row 2, he is now row 1. So from henceforth, the party in the first part, this will be row 1 and this will be row 2.
Okay.
Yeah. Wherever they currently are, that's what the shit they are.
So just to understand the sentence, you multiply row 1 by negative 3, and then you add that to row 2.
And put the answer in
row
row
2.
2. Because it will be a better equation, right? Because it will have less variables.
Okay.
So the whole idea of a matrix is overwrite the old bad shit, replace it with the better shit. Right? Now watch. Okay, here we go. I'm not going to rewrite the matrix. That's what takes forever. I'm going to put next to this, and this is where some of you guys are not going to like, but you can come up with different things. What am I multiplying? Negative 3. So 1 times negative 3 is? 1 times negative 3 is? Negative 3. Negative 2 times negative 3 is? 6. Negative 4 times negative 3 is? 12.
Negative.
Because if I multiply by negative 3, guess what I'm eventually going to do? Divide it by negative 3 again. So why even make it permanent? I just need it for a second to kill this other dude. So when I go to rewrite this now, the first row is still 1, negative 2, negative 4. It didn't really change. I'm just kind of skipping from here to there, right? Don't double it and then cut it in half and waste all that time. So now it's making the matrix a little more useful if I'm not like writing it over and over and over again. So now what do I do for the second row? 0, 11, 13. Oh shit. So Jeff did things wrong. Oh well. Let me see. I made a bogus thing from the beginning. Let me see what was my intention here.
But we get it.
Oh, shit. All right. All right, let's see if you guys can handle this. It's my bad. My bad. Can you guys handle? Just do this. Oh, man.
That's so hard.
Now what is this going to be?
Negative 12.
Negative 12. Okay. That was me just making that a little too fast. Hopefully now I didn't.
Oh, the negative.
Yeah, that works.
So negative 4.
You guys with me? So that should have been a plus 4. That's my fault. So this should have been a plus 4. So now when I multiply it by negative 3, I get negative 12. All right.
That 4 would be positive 4. The one that you wrote underneath it.
Yeah, thank you. Flop. So now what do I get here? Negative 12 plus 1?
Negative 11.
Negative 11. Okay. So when I make a test or a quiz, I have a little more time to double check the answers. I just went through that too fast. Let me stop here for a minute since we had that hiccup. What can I do now? Are you guys, does everybody see the usefulness of this?
Yeah.
It's just you keeping track of what you're currently doing, right? This is important so I can kill the 3, but then the minute it does that, I don't need it anymore. It can go back to the way it was. Divide it by negative 3 again, so it goes right back to what it was. So what can I do with row 2 now?
Times it divided by.
Yeah, what do you want to have here? 1. So divide it by 11. I want a 1 there, don't I? Because right now, what does this row say? 11y equals, and how would you solve that equation? Divide by 11. So anything you would do to an equation is the same thing you're going to do to the rows. Because what are the rows? Equations. 11, I love it. I like that most of you guys are with me. I totally understand this is weird, right? I'm not used to this kind of organization of stuff. Stay with me. Row 2 divided by 11. Put the answer row 2. So what's not right now? What's not quite the goal? Yeah, yeah. So how would I kill this guy?
Divide by 2.
Yeah.
If I divide by
Multiply the
2,
bottom row by 2.
if I divide this by 2, I get 1/2. I mean, it's not going to help.
Add them.
Yeah, add them after what? This won't make it die.
So you just divided it by 11, and now you got to multiply by something.
Multiply by
2.
2. I like it. So whenever you do something, you kind of reset. And you say, I don't want that there. But this row looks beautiful. It's exactly in the right order. I know what y is. Negative 1. This is the row that doesn't have something right. So then in this column, there's supposed to be a 0 there. So I use this guy to make this become 0. So I'm going to multiply row 2 by
Just 2.
2. So twice row 2 plus row 1. Put the answer where?
Top.
On the top, row 1. Because you don't want to screw with this guy. So if I double row 2, what do I get? Twice 0 is? 0. Thank God. Twice 1 is?
1.
2.
2.
Twice negative 1 is? Negative 2. So when I go to write the answer, the second row stays the same. It doesn't become this shit. It's just that shit for a second. And then 0 plus 1 is 1. 2 minus 2 is 0. Negative 2 plus 4 is 2. So what's the answer? 2 comma negative 1. X equals 2. Y equals negative 1. Acceptable. 2 comma negative 1. Also
Would you
acceptable.
rather have throw it in the.
Either way. Either way. Just don't stop here, because this isn't really an answer. There's an answer. X equals 2, Y equals negative 1, or 2, negative 1. Either way. Sorry. Yes.
I got lost. Where did we get the equal sign?
Oh, no, sorry. This is my little arrow.
Sideways, smiley face.
Yes. With a pointy chin. All right.
Is
Now,
there like another shortcut for this or a better way to do this? Because I don't like it.
So no. That's the short answer. That was pretty damn quick. Let's try. All right, you ready? All right.
is so weak.
I
Stay
like
with
that one better.
What's up?
I like that one better.
Which way?
This way.
This way?
Yeah.
All right. For those of you who are not convinced yet,
Yeah, that will work.
let's do a 3 by 3. All right, here we go. What does that mean when I say 3 by 3 by? What would you say the dimensions of this matrix are? That's a weird phrase, but 2 by 3. So, but when I say a 2 by 2 system of equations, I understand it means 2 equations with 2 unknowns in it. But what are the dimensions of this matrix? Like a piece of board, like a piece of wood. 2 by 4. This is 2 by 3. So it's number of rows by number of columns. Right? Same way you'd say there's a 3 by 5 piece of land, 3 foot by 5 foot piece of land, right? Very small. Put your house in there. All right. So let's try. So this time Jeff will be doubly cautious about the equations I write down. Let's see if he can do that. Stay with me. Here we go. I'm going to write the answer right here. We all see the answer, all right? Just so I can keep myself straight. Why are you doing that to yourself? I don't know. -1, -8. Let's see. So this will be 2, 4. It's like 13. You guys all right?
You know the answer.
I like. So you got. I'm done, Professor.
We're so good at this already.
I didn't use matrix either.
Let's see. 11. Yes, -8. All right. Let's see. Let me double check myself. Yeah.
Watch those negative.
13. Yeah. Thank you. Yeah. Okay. Let's do it. See, I don't care how good you are, man. Those negatives find a way. All right. First thing I want you to do is rewrite this in matrix form, and then I'm going to talk about what this guy's goal is. You should kind of be able to tease out what our goal is going to be.
Should we get like ones in a diagonal line?
Hey, yeah, you got it.
Question. So when people do like coding for like ones and zeros,
There you go.
this is basically the
Not
exact
really.
same thing.
This is really related to that, but we are making an algorithm out of the process of solving things. So this, I could code this easily. This process. Computer, take this, multiply it by what you need to kill this, do it again. Take this, multiply it by what you kill it, do it again. It can become a program very easily.
Okay, how do I get that program?
If you have a TI calculator, you already have it.
Oh.
I just haven't shown it to you yet. And it's not good enough to say, I push these buttons. That's my work. Right? I feel like I need to tell you that. So help me out. What's the matrix look like?
1,
1, 2, -8. -1,
Yeah, -1.
2, -3, 13. 5, -1, -1, -8.
Cool. And always double check. If you forget a negative, you're screwed. Okay. And it's already kind of given away, but what's our goal going to be?
1, 0, 0. 1,
1,
0.
0, 0, 1.
Number. Okay, fine. Because then x equals number, y equals number, z equals number. So if we get there, we know we're done. So does the steps we just did for the smaller matrix doesn't change. I just have to do it a couple more times. right?
You said this is the same, like it takes as much time to do this.
Yeah, if I did this the way that was on the handout versus this, it's roughly the same amount of time. This is just easier for bookkeeping, to be honest, so that in that case you might save some. The minute I make this 4, screw the old method, man. That's disgusting. If I had 4 equations with 4 letters, I'd have to kill a letter 3 times. And then amongst those, kill one of those letters twice. So I have to kind of like work my way back. Oh, that shit. But I want you to realize, this idea, if I keep adding more stuff, the steps I take are the same. Find a 1, make everything else 0. Find a 1, make everything else 0. All right? It does. That's why it doesn't really like scale up in time the bigger it is. It's the same steps, just a couple more. Right? Now I am being a little nice because I put a 1 here. Right? So here's the idea when you have a larger matrix. You go column by column. Finish this column. Then move to another column. It really doesn't matter which column you start with. I just always try to start here. Whatever column is the easiest to work with. And this looks pretty damn easy to work with. Right? Now, let me see if you guys are cool with this. Let's see. All right, here we go. Let's see. Well, let's see. I'm going to try. All right, here we go. How could I kill, let me see. How could I kill this 5?
Divided by -5.
Multiply it by 0.
All right. So I'm going to assume you're joking.
Multiply the second row by -5.
So 5
Positive
times by
They're already opposite sides, right? I like it. So if I multiply this row by 5, it will kill this, won't it? So I don't have to use that. Whatever makes sense. Which equations did I have to start with when we did this without a matrix? Any that made sense, right? Any I could see how to kill a letter, right? So here, if I multiply row 2 by 5, you're okay, plus row 3, put the answer where?
Row 2. Row 1, whatever.
Actually, to be honest, it doesn't matter, but you see how I don't want to lose my 1. Those are the easiest. I want to kill that 5. I'm going to put it in row 3, so there's a 0 there. 1s are nice. Anything else, not so nice to work with.
What if you...
Would it be wrong if you put it here and said, no, you just have to multiply this by -5 to kill this, instead of adding these just straight up?